The area of a rectangle is 40 square meters. If the length is 3 meters more than the width, find the dimensions of the rectangle. All right, so let's go back over that carefully and highlight the key information here. First of all, we see that the area is 40 square meters. All right, so we've got a rectangle. Let me draw a picture here. We've got a rectangle. The area is 40 square meters. We want to find the length and the width. All right. And we know that the length and the width are related by this fact that the length is 3 meters more than the width. And we're looking for the dimensions. The dimensions are just the length and the width. All right, so let's choose some variable names. So L for length, W for width. Although you could choose different names for your variables. You don't have to go with the first letters of the words. You could use X and Y or A and B or anything really, as long as you're using it consistently. But length and width, so we could label our square up here L and W for length and width. And now we're going to list the information that we have from this word problem in the form of some equations. All right, so first of all, the area. We said the area was 40 square meters. And we know that the formula for the area of a rectangle is length times width. So L times W is 40. And the other piece of information is this second piece here. Length is going to be related to the width. So length is, that means L equals, and then what do we have here? We got 3 meters more than. So that's a mathematical operation. That's adding 3. More than, 3 meters more than, we're adding 3 meters to the width. So we take the width, W, and we add 3. That gives us the length. And now we want to create a quadratic equation in one variable. Here we've got 2 variables flying around. We want to get rid of one of them to make a quadratic equation. So we go back to our area equation, 40 equals LW, and we use the fact that wherever we see an L, we can replace it by W plus 3 because those 2 values are equal. So we can replace this L here by W plus 3. Everything else stays the same. 40 equals W plus 3 times W. And to make it look, well, to put it in standard form for a quadratic equation, we distribute, we got W squared plus 3W equals 40. And if we move the 40 over, subtract 40 from both sides, we get 0 equals W squared plus 3W minus 40. And now we have a quadratic in standard form. All right, so the next step, we're going to solve this quadratic equation. And we're going to do this by factoring in this example. All right, so pause this video, take a few minutes, and factor this into linear factors like we've been practicing. And when you're ready, unpause the video and we'll check that you got the right factorization. Okay, so hopefully you pause that and work out the factorization on your own. You should have found factorization W plus 8 times W minus 5. And to check that this works, if you multiply 8 and negative 5, you get negative 40. If you add 8W and minus 5W, you get 3W, and W times W is W squared. So when you FOIL that, you're going to get back our original quadratic. All right, and then, so the zero product property, we split this up into 2 equations. We've got W plus 8 equals 0, or W minus 5 equals 0. So W equals negative 8 or W equals 5. But if we think about it, if the width is negative 8 meters, that doesn't really make a whole lot of sense. When we talk about widths and lengths, they're going to be non-negative. The width of a rectangle wouldn't be a negative number in real life. So we can eliminate this. And the only solution we find is width equals 5 meters. All right, so we've got the width, that's one of the dimensions. And then the last step, we find the remaining dimension. So we know that L is W plus 3, coming from this equation here. And we know that W is equal to 5, so L is 5 plus 3. That gives us 8 meters. So length is 8 meters, width is 5 meters. And if you multiply 5 times 8, you do get 40 square meters. So that checks out.